Hello everyone. In this video we will discuss about the various technical requirements for the circuit breakers and different standards which are concerned with the circuit breaker. So first let us have a look on specific technical requirements of circuit breaker. Then we will discuss about some standards which are used for the circuit breaker design, manufacturing and testing, etc. And then we will also discuss the details about the permissible limits for the temperature rise in case of circuit breaker. So first we will see the specific technical requirements for the circuit breakers. So first is the rated system voltage, and generally it is described in kilovolt RMS. So depending on your system voltage, you have to rate the circuit breaker which is going to used in that particular installation. If your system is having the 132 kV voltage, then accordingly your circuit breaker rated voltage will be 132 kV or 220 kV, etc. So that will decided by the system voltage where the circuit breaker is going to operate. Then next is the rated frequency. So in our case the frequency is same all over the India, that is 50 Hertz. So that is same for all the circuit breakers irrespective of the voltage level, that is 50 Hertz. But some tolerance is required to be mentioned. So as per standards, the plus minus 5% tolerance is considered while designing or manufacturing or testing the circuit breaker of this 50 Hertz frequency. The next is maximum system voltage, that is also described in kilovolt RMS. So generally this voltage is more than the rated system voltage. Here we have first seen the rated system voltage, that is the first requirement for the circuit breaker. But also we have to consider the maximum system voltage, because this system is not stable, depending on the various factors. So this system has some maximum value, this system has some minimum value, but maximum value we have to consider because that will affect the insulation system of the circuit breaker. So for that purpose, the maximum system voltage is considered generally 10 to 12% of this rated system voltage. So for example, if your rated system voltage is say 220 kV RMS, then the maximum system voltage will be 245 kV RMS. So that much maximum voltage is required to consider while designing the circuit breaker, or if we specifically say, then it is required for the insulation system of the circuit breaker. So that insulation should withstand this voltage, this much voltage, maximum voltage, continuously. Then next important parameter is the continuous current rating. This is generally expressed in amperes, only amperes. So continuous current rating means that will again decided by the load which is connected to that particular system where we are going to this use to this circuit breaker. So what amount of continuous current is flowing through that system where we are using to install this circuit breaker, so that is also the main requirement for the circuit breaker, that is continuous current rating. So For example, 1200 amperes or 2500 amperes, 800 amperes. So that much amount of current should continuously flow through the circuit breaker contacts without damaging them or affecting their operation. So that is also the important parameter, that is the continuous current rating in RMS, and generally it is expressed in ampere. So next is the type of the circuit breaker. Now there are various types of the circuit breaker depending on various factors. Means if circuit breaker is required to be installed in substation open to environment, that is outdoor circuit breaker. Then if it is required to install in the say package substation which is enclosed, so that is called as indoor substation. So indoor and outdoor depending on the location, depending on the use of insulation, air circuit breaker, SF6 circuit breaker. Air circuit breaker again can be subdivided as air blast circuit breaker or air brake circuit breaker, etc. So depending on various categories, various types of circuit breakers are there. So as per your requirement, where you are going to install that circuit breaker, what is the voltage of your system, because there are LT circuit breakers, there are HT circuit breakers, there are UHV circuit breakers also. So depending on the system voltage also you have to decide, depending on the location you have to decide, depending on the insulation medium used in the circuit breaker, that will also decided by your requirement. So all these continuous current rating, what is the continuous current, short circuit current rating also you have to consider. So different parameters are required to consider to specify the type of the circuit breaker. So that is also one important requirement of the circuit breaker. Then mounting of the circuit breaker. So some are mounted on platform, some are mounted on ground, some are mounted on a steel support structure, some are mounted bolted type, etc. So again depending on your requirement, where you are going to install that circuit breaker, you have to specify the mounting of that circuit breaker. Then the next is number of poles. So single pole circuit breakers are available, 2 pole circuit breakers are there, 3 pole circuit breakers are there, 4 pole circuit breakers are there. So depending on your requirement, depending on your system, you have to decide, or depending on your convenience also, you can, instead of using single circuit breaker of 4 poles for 3-phase 4-wire system, you can go for the 4 single pole circuit breakers for 3-phase 4-wire system. So that is the choice of the system or choice of the design engineer. So which will be more convenient to the system performance, depending on that you have to mention the number of poles. Means you can mention 1 number of poles, 2 number of poles, 3 number of poles, 4 number of poles, etc., depending on your type of system and requirement. Then next is the type of operation. So here depending on the number of poles of the circuit breaker, the type of operation depends. If you are using a single 4-pole circuit breaker for 3-phase 4-wire system, so in that case the operation of all the poles should be simultaneous. Means that circuit breaker all the 4 poles should open simultaneously or close simultaneously. But if you require the separate operation or individual operation of each pole, then in that case you have to go for the 4 single pole circuit breakers for 3-phase 4-wire system, and then in that case you can go for the individually operated single pole circuit breaker. So in that case simultaneous operation is not possible because operating mechanism is different for each circuit breaker. But if that is the 4-pole circuit breaker, then in that case you can go for the simultaneous operation. So that is also you have to decide which type of operation you are required. Then next is the required ground clearance from the lowest live terminal if both the terminals are not in the same horizontal plane. So this clearance is required to be mentioned, and that is generally expressed in millimeters. Means clearance from the ground of the live terminal is required to be mentioned. Again, that is decided by your voltage of that circuit breaker or system voltage, we can easily see. So that the adequate clearance should be there between the live terminal of the circuit breaker and the ground. So that also you have to mention. Then next is the minimum height of the lowest part of the support insulator from ground level. Also this is mentioned in millimeters. Then next is the operating mechanism. Which operating mechanism you required? So there are spring type operating mechanism are there. There are motorized operating mechanism are there. There are pneumatic operating mechanism are there. So depending on your convenience, depending on your requirement, depending on your speed of operation, you have to decide the operating mechanism. So that can be spring operated, that can be motor operated, that can be pneumatically operated. Then next is the auto reclosing duty. Means auto reclosing duty. Once if there is the fault in the system, then the main function of the circuit breaker is isolate the faulty section from the healthy section. So if fault is there and if that fault is temporary, then still circuit breaker is going to trip. But if fault is temporary, then it should not be there in trip position or in open position continuously. So for that purpose, to identify the type of fault, whether it is persistent fault or whether it is temporary fault, so we can go for the reclosing of the circuit breaker. So we can mention the total number of reclosing duties. So if we want reclosing once, twice, thrice, etc. So auto reclosing duty generally preferred is the single auto reclosing duty. Means once the fault is there, circuit breaker trips, and to check the type of fault, we can again close the circuit breaker contacts, and if fault is there, then it will get trips again. Then we can easily know that this fault is permanent, not temporary. If fault is temporary, then the circuit breaker will close the contact and there will be no tripping again. So generally single or in some cases double auto reclosing duty is preferred. Then next is the rated operating duty cycle minutes. So here you have to mention the open, then close, then open, then again close, then open. So between this you have to decide the time. Means once the circuit breaker is open and you have to go for the single auto reclose. So before closing the contacts you have to wait for some time, and that time is generally 0.3 seconds. So when the fault is there, the circuit breaker contacts open, it will wait for 0.3 seconds, then it will close the contacts. So that time of 0.3 second is decided generally as per standard, but depending on your requirement you can go for some different type which can be possible practically. So again close, then open, then again you have to wait for some times, and this is generally for 3 minutes. You have to wait 3 minutes and then you can go for the close. So depending on the type of fault, if that temporary fault is not cleared in 0.3 second, we can again wait for 3 minutes and then we can go for the closing of the circuit breaker contacts. So that rated operating duty cycle that you have to mention. Then next is first pole to clear factor, that is type of tripping you have to mention. So various standards are used to define this requirement. For example, as per Indian standard 62271-100 is there, which is generally used for the specify this requirement of the circuit breaker, that is first pole to clear factor, and this is the type of tripping. The next is the maximum closing time. Maximum closing time. So this is generally mentioned in the millisecond, means the time required for the circuit breaker to close its contact. So that should be fast as possible. So generally this time is 120 millisecond is there for the circuit breaker. Similarly, maximum total break time, so breaking time, and this is very important because this break time is there to isolate the faulty section from the healthy section. So closing times in our hand means when the system is healthy, then we are going to close the circuit breaker contacts. But circuit breaker contacts are contacts are separated when there is the fault in the system generally. So intentionally also we can break the circuit breaker contacts, but that is for the maintenance purpose, or that is for some other work which is required to carry out by isolating that particular section. But generally the main aim of the circuit breaker is to isolate the faulty section from healthy section, and for that purpose this total break time should be minimum as possible. So generally the fast operated circuit breakers are there which uses 3 cycles or 60 milliseconds to break the contact. So 3 cycles or 60 milliseconds. So for one cycle 20 millisecond time is required. Here the maximum time is 60 millisecond, or within 3 cycles the fault should be clear, so that your system will not be affected by the heavy flow of current due to that fault. So for that purpose this is the very important requirement of the circuit breaker. Then next is the 1.2 by 50 microsecond impulse withstand voltage. So depending on the insulation health of your circuit breaker, so this test or this requirement is there, and that is generally measured in kilovolt peak. Then similar to that, the 1 minute power frequency withstand test is also there, so that is expressed in kilovolt RMS. So generally whatever the voltage is used for your insulation design, so generally 2.5 times of that voltage is applied across the insulation of that circuit breaker for 1 minute, and if that insulation withstand that voltage for 1 minute, then that test is passed. So depending on your circuit breaker voltage, this the value will be decided, and that will be applied for 1 minute across the insulation of that circuit breaker. So that is 1 minute power frequency withstand voltage test. Then next is the rated breaking current capacity. So here different breaking current capacities are required to mention. So one is the line charging at rated voltage at 90-degree leading power factor, that is expressed in ampere, RMS amperes. Then small inductive current expressed in RMS ampere, that is generally required for the charging of the transformer in the system. Then cable charging breaking current, that is also mentioned in ampere. Then short circuit breaking current, that is AC component, is mentioned in a kiloampere RMS, and we have to also consider the DC component presence there because of the fault in the system. So that both the components we have to require to consider in case of this circuit breaker. Then duration of short time current in seconds. So what for what time this short circuit current is going to flow through that contact, that we have to mention again. So that is generally up to 1 second. So next is the rated short circuit making current capacity. Means when you are going to use the single duty cycle, so once the fault is there, the circuit breaker contact opens, and to check the type of fault, that contacts are closed again. So if that fault is persist there, then the large amount of current is flowing through the circuit breaker contacts, and that is the rated short circuit making current capacity, that is in kiloampere, because fault current is generally expressed in kiloampere. So this current carrying capacity also decided by the conducting material and its cross section used. So this rated short circuit making current capacity is also affect the cost of the circuit breaker. Then next is the permissible limit of temperature rise. So we will discuss this permissible limit of the temperature rise in coming slides. Then maximum acceptable difference in the instance of closing and opening contacts. So that is again as per your requirement, single break is required, so then we have to mention this one. Then minimum creepage distance of the support insulation, so that is also mentioned in millimeter, and that generally say 6125 millimeter as per standards. Then short time current carrying capability for 1 second, that is also in kiloampere. Then rating of auxiliary contacts, so that are generally if DC is used, the 220 volt DC, and current will be maximum 10 ampere is required for the auxiliary contact rating. And number of auxiliary contacts, how much interlocking you are going to do in your system, depending on that the number of auxiliary contacts are there. Generally 10 NO contacts and 10 NC contacts are kept spare for the interlocking of the system for the safety purpose. Then breaking capacity of the auxiliary contacts also you have to decide. Then seismic acceleration, that is horizontal, that is expressed in gram, and then minimum corona extinction voltage also in kV RMS is required. Then number of closing and tripping coils, so generally 2 trips coils and single close coil with anti-pumping arrangement is provided in case of the circuit breaker. So this is about the specific technical requirements of the circuit breaker. Now we will discuss the standards which are concerned with the circuit breaker. So first we will see the IEC standards, and that we will discuss the IS standard. So first standard is IEC 62271-100. So this standard is used for the specification for the alternating current circuit breaker. The standard is used for the specification of the alternating current circuit breaker. The next standard is IEC 62271-203. This standard is used for the gas insulated metal enclosed switchgear for rated voltages above 52 kV. The next is IEC 62271. This is 2 is missing here. This 62271-1, and this is used for the common clauses for high voltage switchgear and control gear standard. The next is IEC 62271-102 is used for the alternating current earthing switches. So it is also used for the induced current switching also. The next IEC standard 60137 is used for the bushing for alternating voltages above 1000 volt. The next is the IEC 62271-209. This standard is used for the cable connections for gas insulated switchgear. The next is IEC 60480. This standard is used to check of the sulfur hexafluoride taken from electrical equipment. So for that this standard is used. Then IEC standard IEC 376. This standard gives the specification and acceptance of new supply of sulfur hexafluoride. So for SFC circuit breakers, these both standards are required. The next is IEC 60947 is the degree of protection provided for enclosures for low voltage switch gear and control gear. Then IS 325 is the specification for 3-phase induction motors. Then IS 2516 is the specification for high voltage alternating current circuit breakers. Then IS 2629 is the recommended practice for hot dip galvanizing of iron and steel. Then IS 2099 is the high voltage porcelain bushing. This standard is used for. Then IS 2486 is the specifications for clamp connection of the circuit breaker. And then IS 2062 is used for the hot rolled medium and high tensile structural steel, which are used for the circuit breaker installation. So these different standards are used for the circuit breaker. So now the one point which is missing is the permissible limits of the temperature rise, as we are discussed in the requirement of the circuit breaker. So let us see that table here. So here all the details regarding the temperature and temperature rise at maximum ambient air temperature is given. So here contacts, if the circuit breaker contacts in air and are made up of silver faced copper or copper alloy or aluminum alloy. So for that purpose the temperature is 105 degrees centigrade, and temperature rise at a maximum ambient air temperature not exceeding 50 degree is the 55. So if we are considering the 50 degrees centigrade is the ambient temperature, then the temperature rise is 55 degree. If the contacts are bare copper or tin aluminum alloy, then in that case the temperature is the 75 degrees. So temperature rise is only 25 degrees centigrade here. So terminals to be connected to external conductors by screws or by a bolt silver face, then again the temperature is 105. So 55 degree centigrade rise is allowable. Then for metal parts in contact with the insulation of the following classes. For class Y, if that is there, then it is 90 degrees, so temperature rise is 40 degrees centigrade. If class C insulation is there for used in air, then 120 degrees centigrade is the temperature, so temperature rise will be 70 degrees centigrade. If class B is there, then 130 degrees centigrade, so temperature rise will be 80 degrees centigrade. If class F in air is there, then temperature is 155 degrees centigrade, so temperature rise is most, that is 105 degrees centigrade temperature rise is there if class F insulation is it. And if synthetic is used in air, then 120 degree temperature is acceptable, and that temperature rise will be 70 degree centigrade allowable. So here we have to note that when applying the temperature rise of 55 degrees centigrade, so care should be taken to ensure that no damage is caused to the surrounding insulating materials. Also we have to note that the quality of the silver facing shall be such that a layer of silver remains at the point of contact after the mechanical endurance test. Otherwise the contacts shall be regarded as bare. Then the values of temperature and temperature rise are valid whether or not the conductor connected to the terminals is silver faced, and the temperature shall not reach a value where the elasticity of the material is impaired. So for pure copper, this implies a temperature limit of say 75 degrees centigrade. So this is all about the requirements of the circuit breaker, its contacts, standards and temperature rise. So thank you.